Hi guys, my name is George Inshrakujo, together with my group member Janice Nyamison Kakra. We are students of Petrochem 2, and we worked on a project known as the Disease Spread Simulator. So, as the name implies, the project works by collecting input from the user and produces a simulation of how disease will spread if there was an outbreak in that particular setting. So the input specified by the user include population size, day of lockdown, the number of days of simulation, lockdown effectiveness, rate of disease spread, rate of vaccination, and rate of recovery, as well as the number of people who were initially infected or the number of people who had recovered from in the beginning. So let's move on to the code. The code allows us to uh, specify inputs, gives a breakdown or a summary of whatever simulation progresses. And at the end of the simulation, I get an output that gives me a summary of whatever goes on, such as, for example, um, I have infected people, they also recovered, susceptible to the disease, and the mild cases. It gives me information about all those. And also, okay, let's move on to the running of the code. Okay, so my first input is to label my population size. So I'm going to use 2000. The number of days of simulation maybe 30. Initial infected, I'm going to use 20. Rate of infection, I'm going to use 0.4. Recovery rate, I'm going to use 0.1. Vaccination rate, 0.02. Lockdown day, I'm going to use 15. Lockdown effectiveness, so maybe 0.5. And note that this code also rejects any input that isn't required. So, for example, if I input 0.1 where the input is supposed to be greater than 5, I'm going to get an error. And it's going to produce that dialog box for me to retype the info. So I'm running that. And it gives me three simulations. So one on a scatter map. So the green here indicates those who are recovered. There's a hotspot that indicates severity of disease spread. There are yellow portions that indicate those who are susceptible. And note that these shapes indicate people moving in the city that are actually being infected, that are recovering and stuff. I also have my bar graph here that gives me a live representation of all information related to the scatter map. So, for example, I have recovered number, severe, mild, susceptible, and I also have a graph that gives me a breakdown of whatever just happens. So, I can see that the number of susceptible people have decreased initially from around 1750 to almost zero. Yeah, so after the simulation, I also have buttons for increasing simulation speed and for pausing and resuming the simulation. After the simulation, I get a summary that gives me the total number of people I chose, number of susceptible people. Those are the people who were never infected but were prone to being infected, mild cases, severe cases, recovered, total infected after the simulation. So by all means, after the simulation, some people uh, will still be infected based on my input. I also have explanation. What are susceptible, what are mild cases, severe cases recovered. And I also have fading trails that show movement, hotspot size, and severity concentration. So basically, that's it for my code. Thank you very much.